What is up, everybody? This is Mac with Craftmaster Stainless in our warehouse here in Rancho Cordova, California. Right behind me here is a custom extraction skid that we just built for UC Berkeley. We've been dealing with their alternate food laboratory there, working with Dr. Ricardo San Martin. They were passed on to us from a very well-known company in both the brewing industry as well as just lab equipment. Anton Parr, who makes some very well-made sensors, meters, things like that we can use on our equipment. He contacted me saying they have a guy looking for a custom piece of equipment. So what UC Berkeley is doing with this is they are creating a compound that is then used for emulsifiers. They've been using smaller, almost homebrew size equipment for the last couple years as they've been dialing in their process. This is the first step for them to then bring it into more professional equipment as we then step it up into different sizes. So here we are going into detail of the whole system. We're going to start here with the control cabinet. This is a UL certified control cabinet. All you have to do with this whole skid is bring it into your warehouse, if whatever piece of equipment you go with, and have an electrician wire it up. Everything else should be taken care of on our end. Here we have it all set to the parameters and the settings that we discussed with UC Berkeley. So there's readouts of temperature, there's pump speeds, there's mixing motor speeds. We're also reading pH, oxygen content, and then we also have an Anton Parr Brix meter that's reading the total Brix content of the liquid that they are extracting. So basically, if I need to add hot water into the mixing tank, I can set how many gallons of water I want. We have an IFM flow meter on this machine that will then stop the flow once it reaches the total amount of water that you want. Then once we go into the mixing tank itself, I can set the mixer speed, and then I can set the time for how long we're gonna mix it. So for them, they can't over extract the compound or over beat up the material that they're using, and so they need to time that specifically. We can also then go to the transfer speed as well as the transfer gallons. So if they're targeting a certain amount of gallons in the fining tank, they know what they're going to reach over there. And we have the options because we have two different filters. We have a basket filter as well as a lenticular filter. The basket filter will always be in line to filter out the media. And then the lenticular filter will be used in different instances. So yes, I can transfer through the filter, or no, I don't have to. As we go down the line of the settings, we have the fining tank circulation, so I can recirculate it in the fining tank. I can mix the fining tank. We also have a glycol jacket, which is automatically temperature controlled through the PLC and HMI, so I can set the cooling temperature of the fining tank. So the fining agent that they're using, we have a separate fining tank over on the very end of the skid where they are dosing their fining agent and mixing that with water. That is also hooked up with a IFM flow meter to accurately measure the water that's being mixed with the fining agent. And we also have a flow meter that measures how much of that liquid is then being transferred off into the fining tank. These guys are engineers, they're scientists, everything is accurate, and they're always messing and fine-tuning things in their craft. And so that's why we have so many flow meters in here. The fining tank also has a cooling jacket. I can control the cooling temperature from the screen as well. And then they're dosing each tank with either a basic compound or an acid compound to adjust the pH of the liquids at certain points. I can choose how much of that I need to dose into the tank at a time. That's why we have the pH meters, the pH sensors in here, so you can adjust that. That covers pretty much the touchscreen controls. You can set up different user interfaces in here, as well as like your logins, whoever's using it for that day. But that pretty much covers the controls of this custom skid. Alrighty, so this video is going to be in detail of what this skid actually does. So starting right by the control cabinet is the digital pressure regulator. So the system will throw an alarm if, one, it's not hooked up to air, two, that air pressure is too low to operate the pneumatic valves that are positioned throughout this whole system. We're going to start with the hot water tank. This is a 200-liter hot water tank with an electric heating element inside. It can autofill. It will also stop the pump or turn off the heating element with the level sensors that are positioned inside. You'll see a shot of that coming up here pretty soon. So if the water level gets too low, you don't want to damage your pump, turns off the pump. We also make sure that your heating element does not burn itself out by accidentally being turned on. And then when you need to refill it, it can autofill to the high level sensor and automatically kill the water so you don't overflow and flood your facility. Through the process, they're adding this hot water into the mixing tank. Inside the mixing tank is where they are adding their media that needs to be mixed, and then the compound gets extracted. In here, there are a couple different mesh filters that the engineering team at UC Berkeley figured out what size works best for their process. And so there's an internal basket filter where the media will go in, as well as almost like a false bottom that you would see in a brewing mash tun. And like I said, they did the sieve testing themselves and provided that mesh, and we installed that so that it filters what they need to filter. You can add that either through the top manway or flip open the door. Inside there is a bottom mounted agitator. You'll see that in another shot here as well. That agitator is VFD controlled through the screen. We kind of went over the timing of everything. They can time it and control the speed of that agitator. From the mixing tank, we go through a basket filter. This basket filter will filter out any media that did not or did make its way through the really fine pieces. It will be trapped inside of here. Going through, we have a lenticular filter that is currently at the university that will install right here. It's going to be about yay tall, and that lenticular filter is filtered to where you're almost creating an ultrafine trap. You're filtering out almost everything out of the liquid that they're producing. I can either bypass that, depending on the level of filtration that they need for what they're doing. I can either go around the lenticular filter into the fining tank. We have a flow meter positioned going into the fining tank so you can track how much liquid you have transferred. That helps with the accuracy of dosing chemicals and fining agents. Or what I can do is then go filter, filter. It comes in here even more filtered than before. Inside the fining tank, there is also a top-mounted agitator and LED light so you can see inside. The fining tank is glycol jacketed, which is positioned towards the back. They have the option now, if they need to filter the compound again, they can come out of the tank through a pump, wrap it back around through the lenticular filter, and then you can track again how much liquid you've filtered through at that point. Once this is all fine, they have a couple methods of where these compounds are being transferred to or what's used for what. I can't really go into too many details as it's a little proprietary to the university. The fining tank is the last, or the fining agent tank is the last piece. They're using a certain fining agent that is being dosed through the top. We also have a flow meter here, so if you need to set how much water goes through this, it goes into the tank, and then you dose that. There's an agitator in here to make sure that it reaches a homogeneous mixture. One more flow meter coming out of the fining agent tank into the fining tank. This tracks how much of that chemical we just added in for accurate dosing. This whole thing, like I said, took about a year to design on and off with the tests they were doing at the school. But I'm pretty confident, and we just had a meeting with them yesterday, that this is going to create what they want to create. It was a really fun custom project to do. It's very different from, our standard brewing equipment. And that's one thing that we really want to point out to everyone who reaches out to Craftmaster for any project is tell us how you need to move liquid, tell us what you're doing with that liquid, and we will build the equipment to the exact specification that you need. Thank you for watching this video. Keep an eye out for any more. Cheers, guys.